Assalamualaikum. Today's topic is chapter 16 of machine design: clutches, brake, coupling, and flywheel. Going to the theory of these topics, clutches and brakes, even flywheel and coupling, that are a group of elements usually associated with rotation that we have common function in the storing and or transferring rotational energy. Because of similarity of function, clutches, brake, coupling, and flywheel are treated together. What is the difference? Let's say we have an input power provided here, and here is an output power. Here, if we have a clutch, what is the function of clutch? If we engage the clutch, it disengages this left hand power transmission from left hand, and this power transmission is disengaged, and input power is provided continuously, but this belt will be rotating, and this belt will either be rotating or not rotating depending on the inertia of this right hand side. So that is the function of clutch, either to disengage the system or to engage the system. When clutch disengages, again this will come in contact with this system, and complete system will start to rotate at a constant rotational velocity. And the function of brake is also the same. In brake as well, when we apply a brake, we push this system to come in contact with this left hand system which is rotating at the speed omega, and after connection both of the system start to rotate at a constant or at a fixed or constant speed, uniform speed. And in case of brake, this system is grounded. As this system is grounded, it cannot rotate, and so the uniform speed is 0. It depends for how much long time we press the brake. This right hand side try to stop this left hand side when brake is applied. When the clutch is applied, both of the system rotate at same speed, but in case of brake, rotational speed of one system is 0, so the common speed for both left and right hand side are 0. Whenever brake is applied, whenever we apply brake, the energy of the system drops. For example, if a car is moving at a velocity, it has a mass, so it has an energy of half mv square, or half mv1 square, the velocity before applying a brake. Let's say we apply a brake. Due to application of brake, the velocity of car decreases, which causes after brake, if car does not stop, but even if the speed is decreased, the new energy, kinetic energy of the car is half mv2 square. So the initial energy was half mv1 square is k1, and k2 is equal to half mv2 square. So any drop, if you see here, the energy is depend on square of velocity. So any drop in velocity will cause drop in the energy. So if there is a drop in energy, the remaining delta k, the drop in energy is lost. Where it is lost? It is heat. Heat is generated in the brake. As a result, temperature of the braking system increases, so that heated brakes are due to change of energy. As in case of trucks, they have larger mass, so same change in velocity for truck causes more loss of energy, so more the brakes will be heated. So the lighter the system, for the same velocity difference, less loss of energy, there will be less loss of energy, or less heat will be produced. For larger masses, in case of train, for same delta V, as the mass is a lot, the energy will be a lot, the loss of energy will be a lot, and the heat generated on the brakes will be more as compared to car, or as compared to bicycle, or as compared to motorcycle. So in analyzing the performance of these devices, we are interested in the actuating force, how much force we are required to stop, how much torque is transmitted. Torque transmitted means if the clutch is disengaged, torque is transmitted from rotating body to the stationary body. In case of brake, again torque is transmitted, but that torque is negative. If a body is rotating at a torque value T and it comes to a stop due to braking, that minus T will be the torque transmitted. Energy loss will be due to any change in velocity. There will be loss of energy, and that loss of energy will cause a rise in temperature. The torque transmitted is related to the actuating force, the coefficient of friction, and geometry of clutch or brake. So there is different type of braking system or clutching system have different type of transmitted torque, and it also depends on coefficient of friction and actuating force. The good thing is that this problem is the problem of status, because a body is moving, and moving body is either comes to a stop, or either it changes its inertia. It's not inertia. It's rotation velocity. Either it changes its rotation velocity, or a whole system comes into equilibrium, into same rotational speed. However, the temperature rise related to energy, so any loss in energy will cause change in temperature, and that will be positive thing. Positive thing is change in temperature will be positive, or temperature will increase. In the book, they have given a lot of types, either 6 or 7 types, but I have chosen only 4 types. It depends on time, how much time we've got. It depends on that, how many types of clutches or brakes we will study. Flywheel. In the car, if you see, after the clutch and gear, there is a flywheel. And what is the function of flywheel? Let's say your car is moving. The speed of engine is, let's say, 2000 revolutions per minute, the rotation of engine. And the rotation of your car, speed of your car depends on the speed of wheel of the car, and that depends on the on gear. Which gear you are applying. For example, for same 2000 RPM in first gear, your car will move about 20 meter per second, 20 km per hour. But for the second gear, it will probably move at 30 km per hour for 2000 RPM. For third gear, same 2000 RPM can give you 40 to 50 km per hour. But fourth gear will give you, for same 2000 RPM, give about 70 to 80 km per hour. But fifth gear will give you about 80 to 90 km per hour. So engine speed is same. In all cases, engine speed is 2000 RPM, but output depends on the gear, which gear you are applying. So whenever you engage the clutch, you disengage engine of the car, which is running at 2000 RPM, from the wheel or from the moving parts of the car, from the actual motion of the car. You disengage them. But whenever you disengage them, your car moves with a constant velocity. Why? Because your car has an inertia. Due to that inertia, your car moves. It does not stop. The function of flywheel is the same. If your car is not moving and you are changing gear, or if even it is moving, the slow motion or the flywheel provide your car a constant output velocity. So the another function of flywheel is that if there is an engine of the car, and engine of car we have 4, let's say you have 4 plugs. After each 90 degree of rotation of crankshaft, each plug is providing a power. So you have a power stroke here, you have power stroke here, here and here. So if you make a graph on the horizontal scale, you have a power stroke here. For remaining 90 degrees, there will be not any power stroke, but suddenly after 90 degrees, you have another power stroke. So the omega input from the engine will be discontinuous. So what the flywheel will do, it stores this energy, this discontinuous energy it stores, and it provides a constant output omega. So it stores the energy from the engine, and it provides energy in terms of T and theta. In terms of omega, it provides output power to the car wheel. So that is the function of flywheel. It stores the energy from the input source, and it provides the energy to the output source. The braking system, before going to into the detail of braking system, in the book they have given an example of static example of braking with an of a door stopper. If you see here, they have placed a door stopper on the door, It's what is its function? When we move door here, as the force applied on door stop is in this direction, it will apply force on the ground, and due to as there is a rubber, it will try to stop the door moving towards this direction due to friction on the body. So its process can be related to braking system. So in this topic we will study how we can calculate forces in this door stop. So what are the steps? Estimate, model, and make the pressure distribution on the friction surface. So on this surface we have to assume the pressure distribution. Then we have to find a relationship between largest pressure and the pressure at any point. So if we know the pressure distribution on the surface, for example, this is a pressure distribution, we have to calculate at which point we have the maximum. For example, if you have a pressure distribution equation, just differentiating this by partial u will give you the point where the pressure distribution is maximum, and substituting that value of u in this equation will give you PA, which is equal to P max, pressure max. So this is how we use that. But another method is used as this pressure distribution as constant, or simply if you know the P, so P is equal to P average multiplied by area, which is equal to W1 W2. So P average W1 W2. So this P average is the uniform pressure distribution throughout the area. So at any point you will have a pressure P average, and P average will be also equal to P max, which will be also equal to P min, because there is not a single point which has a different pressure distribution. So if we assume this problem as a uniform pressure distribution, we can use this equation for solving the problem. We don't need to go into this detail. That's what we will do in this topic. And once you know the pressure distribution, you can calculate static forces and moment. So this is the equation. If you know the equation of pressure distribution PU, as here we assume that this PU is constant in this direction, so it will not have any effect in W2. So any changes in this direction will be same throughout. Each cross section will be same. So W2 is out of the equation. So we have a pressure distribution PU. What is DU? U starts from here to this point. So for every small strip we have a pressure distribution of PU, and multiplying it, it has a small width of DU. So PU DU is integrated from 0 to W1, we will get multiplied by W2, we will get N. And if you assume that this pressure distribution is uniform, so it will become P average, which will come out of the integral. We will left with 0 to W1 DU, and integral of which will give us U 0 to W1, and substituting value will give us W1. So W1 multiplied by W1 W2 P average will give us this equation. So we will be using this equation if we assume that pressure distribution is uniform throughout the cross section. If it is not uniform, we will be using this equation. Similarly, if from here we get an equation of N, we will also know how we got this equation. We assume that there is a small strip. For this small strip we have a pressure of PU. That small strip has a width of PU, and it lies at it is x as a distance u from this point. So its moment, the moment of this force will be equal to PU du multiplied by this moment arm, which is u. So PU u du is the moment of this force, or moment of this N about this point. And again, if you by any means you calculate N, if any means you can calculate N, the distance of this N from this point will be U bar. And what is U bar? U bar is the distance of point of action of force from the end of the doorstop. So if you use P average, if you use P average, as at all the points pressure is uniform, so the force will pass through the centroid. In that case, U will be equal to U bar will be equal to W1 by 2. So that's what we have used here. U bar is equal to W1 by 2. So that will be used here. Or otherwise, if you are given the pressure distribution, you can use this equation. But in this course, I will suggest you to use this equation instead of using these equations. Now, the second step is to calculate reaction forces. For reaction forces, we have two methods. One is that the door is opening and the second is door is closing. Let's say here we study the door is moving towards right. I think I have started, floor moving towards right. Floor moving towards right, or in this equation, if the door moves towards left, the floor, relative motion of floor will be on the right. So either we are using door left or floor right. Both things can be used. If floor is moving towards right, floor is applying a frictional force in this direction. And what is the magnitude of friction force? F into N. And what was N? N was here, which we have already calculated using this. And in case of P average, N will be exactly at the center. So the distance of N from here will be equal to U bar equal to W1 by 2. So this is a frictional force, and there is a force here which is Rx, because this is our positive axis. So if we summation Fx equal to 0, it will be, because both the directions are same. So Rx plus, what is this? This is equal to, if you see, it's the same equation like this, but with a addition of F. So it is F into N. If you are using P average, we can just write it as Rx plus W2, W1, F into P average, which is integral equal to F into N. So anything you can use. So this is the equation of Fx. The second and modifying this equation, taking Rx, keeping Rx here and moving this on the other side, you will get minus here, and similarly you will get minus here. So minus Fw1 W2 into P average. You have to keep in mind where to use plus and where to use but. I am solving for a right floor motion. For left floor motion, I am just writing it. For left floor motion, this will be minus, this will be minus, this will be minus, and this will be plus for left floor motion. And I just changed the color for minus and plus for left floor motion. Similarly, summation Fy. Now, second thing is we have to solve for Fy. There was N here. Summation Fy equal to 0. What are the forces in y direction? Ry plus N minus F. So Ry plus N, this is N. Exactly same equation as this. Either this term or this term, depend on what you use, minus F. So solving it is minus F plus N plus Ry equal to 0. Or you can just calculate anything you want, either F or Ry. So Ry will be equal to F minus this term, or F minus P average W1 W2, or F minus N. So this is second equation. Third equation is summation of moment. How we calculate that? Summation of moment at this point. To calculate that, we have just remember our motion of this was towards left, floor was moving towards right, so we had a force F into N here. So what will be the moment? This F will cause a counterclockwise motion. This Fn will also cause a counterclockwise motion, and this N will cause a clockwise motion. So this F into B will be positive. Fn will be Fn. This term will also be positive for right floor motion. This will be positive, and this this N will be negative. So these two will be positive, and this will be negative. Vice versa, for just by changing color, if you have left floor motion, in case of left floor motion, the direction of Fn will be here. So this term will be in this direction of motion of N. So this will be negative. For left floor motion, this will be negative. For right floor motion, this is positive. So once you have this equation, we can have the next equation which is FB. For FB we have placed this term towards right. So W2 integral of P plus U, this term become positive and this term will be negative for right floor motion and positive for left floor motion. That you have to keep in mind which sign is for which value. So all the red signs are for right floor motion and all the green signs are for left floor motion. Now the one question remains: if it is possible that this F is negative, if it is it possible or not? F is equal to 0 or F is less than 0, if it is possible or not. If you see here, in case of left floor motion, or what is left floor motion? Just go here. Left floor motion is here, which means that door is moving towards this direction. Door is moving, or we are closing the door. In that case, both the values are positive. This is positive and this is positive. So it is impossible that the sum of two positive values is 0, because neither C is 0, neither pressure distribution is 0, neither coefficient of friction. So these values are non-zero. Both of these values are non-zero. So it is impossible that the final answer is either negative or 0. So it is only possible to be 0 when we have a negative here, or when the floor is moving towards right side. So when the floor is moving towards right, we can have a negative sign here. We can say that if the floor is moving towards right, we have a possibility that overall this term is either less than or equal to 0. If this term is less than or equal to 0, it means that we required 0 external force to stop the door. Even if this force is 0, the door stop will stop the door. So this equation is that. So if F is either 0, if F is less than 0, it is called self-energizing or self-stop, self-break. Or if it is not equal to 0, it is not self-break. So solving it again, separating F from this equation, it will give this whole equation like this. And what we have done here, we have separated two terms, one with C and one with U. C, this is the term PU C du and PU U du. We have separated these two terms. Now if you see that if the integral of PU du, if you know that if you calculate the pressure distribution, this U can become out of the equation, because U is the distance from this point to the point of application of force. So U bar can be calculated. So the whole term will be equal to C plus U bar integral of 0 to W1 PU du divided by integral of 0 to W1 A multiplied by PU du. So we will have same equation here and here. It will cancel out. So the final value will be C U bar by A. So if in any case the critical or value of coefficient of friction is more than these values, the door stop will act as a self-stopping or self-braking mechanism. And what is C? C is this distance. If you see here, C is this distance from here to here. A is this distance, and U bar is the distance from this point to the point of action of force. So all these three values depend on the geometry of the system. So if you calculate, let's say if you know all these values and you calculate F critical is equal to 0.6. So only it depends that, and if door stop that you buy from the market, it has a value of F equal to 0.4. If it has 0.4 and F critical is 0.6, it means that you have to apply some external force to stop the door. Or if you want that the door is automatically stopped, either you can increase the coefficient of friction of this bar by adding some extra material, or either you can decrease the value of critical friction. You can either decrease the value of this, so F critical has to be more than F, F critical has to be less than F to being able to self-stop or self-braking. It has to be less. So to decrease that, either you can decrease it or you can increase it. To increase it, you have to add extra material or softer material, or to decrease it, you have to decrease this value. And how can you decrease that? Either you decrease C, either you decrease U bar, or either you increase A. By changing these values, you can increase F critical and you can decrease that F critical, and if this equation is satisfied by any means, the door stop will be self-braking. So this was the theory of today, and I have solved the problems in the class, and I hope that you have understood the way I have solved the problem.